So let's say if this is your layout, if you want to do extraction on this, you need to first open caliber X. So it's something like this, the rules files, you can find it. So the place where you've been getting your TRC and LVS files, same place you can get this caliber.r6. So here R6, and you need to select this file. Other things are like similar to LVS, selecting the schematic viewer, export from layout, etc. Here, make sure to select transistor level R plus C plus CC. CC means capacitance between two different nets. C just means capacitance between a net and ground. That's how I understand it. In format, you can select one of these three: caliber, DSPF, or SPEF. SPEF and DSPF, they are pretty much same. So let's say if we select DSPF, use names from schematic. Other things you don't need to change. This you can make sure that it is for all nets. What it does is it calculates all the capacitances, resistance, creates a netlist. That netlist is in the format of DSPF. That we need to save somewhere, and while running the simulation, we need to use it. It's the same method for SPEF. This file you have DSPF 1.5. You can see like here it says how much capacitance is there between any two nodes and all of this. We save this. This thing seems to have crashed. So I just, oh, okay, yeah. So this dialog box will get here. You just select some folder. Here I've done this land DSPs. I'll just save it here. This you can close it now. Another thing which you should look at before closing this is you start RVE. So you can look at the results here. So here you can see how many resistances are there, capacitance, what's their value, and you can also see the details in which layer it is and what value, all of this you can see. And anyways, all the comparisons, because in order to run X, that is extraction, you need to clear your LVS first. If DRC is not cleared, it's fine, but LVS needs to be cleaned. uh, Along with this, I'll show how to run simulations later, but there's another thing that you can do. Similar for SPF, you get just a file here. You can do caliber view. Use names as schematic. Okay. Run accident. You just need to follow one of these. You don't need to do both of them. I'm just showing for the sake of demonstration. Hmm. So again, it does make a file like this, but you don't need to save this and use it anywhere. You get this dialog box, caliber view setup. Netlist it anyway selects. If it doesn't, you'll have to debug it, like find out where it is storing it, and probably find it here. Output library, cell map file. This is important. So the place where you got your R6 from, caliber.r6, there's this calview cell map. So you need to use this file. So put the path to that file here. Make sure that it is working correctly. You can just view it. Then what view name you want to store it as, that you write here, and you can do some of this array. And once it is done, it will read, it will open it in read only mode. You can check the progress in the terminal. Hmm. So it has just taken the all the like these are the actual devices. Everything else is parasitics. It has just arranged them in a schematic. If you have a larger design, if you have multiple modules in it, it will flatten it completely. So what you see here is just all the MOSFETs in a line, then all the resistors, all the caps. It becomes extremely difficult to debug anything in such a design. Hence, it might be recommended to use DSPF for uh, extracting parasitics. But all three of these methods should yield in the same results. Now, something interesting is happening here is that if you see here VDD, both these are small. Out, these are also small. But in the schematic, if you see this that we just created, VDD and out, these are uppercase. This will cause issues. So even if you don't like find out these issues right away, uh, you'll get notifications in your terminal, and it will say fatal error because port mismatch or something. So you need to change these. So be careful about this. Generally, I've seen with other designs as well that this does seem to have issues uh, with its ports. Generally, it's not simulation breaking, but it does have issues with ports. This calibrating. Now, after this, once you've done this, if you're if you're using a DSPF file for a simulation, I'll just show the test bench. I've made a symbol for the NAND gate, and I'm giving this signal here. And just using ADL, same things apply in Maestro as well. So if you're using Explorer, you can do the same thing. Simulation files as well, revert things back to normal first. Yeah, so when you're opening ADL, if you've noticed it, it says library name, schematic name, and schematic. Schematic in itself does not mean schematic, but actually the cell view. You see here, TB assignment 3, schematic. That is the cell view that it is operating on. You can have a schematic 2 as well, schematic 5 as well. And if you're running ADL, you need to check which thing it is working on. So what we're doing, we're keeping the schematic same as before, but in parasitic files. So what I've done, setup, simulation files, this. You need to give the address. So wherever you save this file, you save this as 9 DSPF. Otherwise, you can do this as well. You just need to do one of them, SPF. So I'll just select one of them. Okay. Now if I run simulation, it will run with the while considering the parasitics. Yeah. So in such a design, I don't know if you'll be able to see any significant differences. We'll change its color to green so that in the next go we can see what is different from without plastics. So you see here there is some difference. The one considering the parasitics has a higher dip here, but in general it doesn't seem to be much different. I guess the spike here would also be different. Yeah. So there are differences. In such a design you won't see much. Along with this, there's same thing you can do for this. So SPF file if you have, you just select this. Now the caliber view that we made, how to use that. You can see this caliber underscore RCC. So for this you need to change the design. Also one thing I should clarify here for this, what we're doing, what we're using the DSPF and SPF files for is this design. We're not generating it for the test bench. And if you have multiple of these blocks, I have not tested it myself, but I believe you should be able to just add them here. So in the simulation file setup, you can just add multiple files here for each of the blocks, and it will catch it accordingly. Now, if you want to use caliber view, you need to change the design itself to config. And this for the test bench. Test bench, we have a view name config, and we're going to use that in ADL. You can see here as well. So it is running on config, and the config is based on the schematic. Here as well, it says config. I'll show what the config file is. So here, if you, yeah, it is already. So otherwise I'll just generate it again. Yeah. So if you want to generate a config file, just file, new, cell view, config. So in type you select config, and in here view schematic, expected. Library list you can just ignore, it doesn't really matter. So save it first. What we're doing is it just shows all the modules which are present in your test bench, where they're coming from, what view you're using for them. This is the purpose of this config file. You can you can specify in great detail that which module should come from which library, should use which either Verilog code, whether you should use schematic, whether you should use the extracted schematic, all of that. So here we just set it to caliber RCC and update. Okay. So once it's done, let's see that this ADLB is out. It is running on the config. Hmm. Here as well we are seeing all the spikes and everything. That is how you do parasitics extraction and how to run simulations on them. All three methods are there. You can use any one of them.